Sometimes firms have to choose among different projects that vary in their economic lives, costs, and other input variables, and using NPV to assess them creates problems. A project with a longer life, all things equal, has a greater chance of larger NPV because it has more cash flows to discount than a project with short life. However, this might not be the right decision. Perhaps if the discount rate is high, it is better to have a shorter project. To ensure we compare apples with apples, two methods of solving these problems are applied. The first is the project replication, where we reproduce the shorter project until it has the same life as the long project. The second is to use an equivalent cost or benefit, where the net present value is converted to an annuity for comparison. Similar to the annual equivalent rate when we have different compounding rates of interest. This is an example of project replication. The company has a choice between two machines. Machine A costs less and has a life of 2 years, and its NPV is 1.2. Machine B costs more and lasts only 1 year with a lower NPV of 1.1. So based on the NPV, we would reject project B. However, if we replicate B 1 more year, we have the same 2-year life for B as for project A. We have a common denominator for comparison. So when B finishes in year 1, we buy it again. We apply the NPV to the sum of cash flows from the original and replication, and we see that NPV is higher than the project A in that case. This method has the disadvantage that sometimes we have to replicate a project many times to arrive at a common ground for comparison, which can be time-consuming and cumbersome. For example, comparing a 5-year and a 3-year project would require 3 replication of the 5-year project and 5 replication of the 3-year project to get to the same denominator for comparison. The second approach is to transform the NPV into an equivalent annuity and then compare the two. This approach takes in consideration the different initial cost and the different cash flows and calculates an equal amount per year. Using the present value of annuity formula, we ask, what would be the equal payment that when discounted back will give us the same value as the NPV? We isolate the cash flow or the equal amount and solve the equation for the two machines. On a yearly basis, machine B again is the better choice as it offers us more. When analyzing the costs of two projects, we perform the same analysis bearing in mind we are using costs, therefore negative cash flows. The resulting NPV will be a higher value than the initial cost, and the equivalent annuity will be a negative value. Then, of course, in that case, we choose the project that costs us less per year, the lowest equivalent annuity. In theory, we assume that all worthwhile projects can be accepted and financed by the firm. However, in the real world, we often find firms that have positive NPV projects but cannot obtain the necessary financing for all of them. One reason could be that there is not enough personnel to be allocated to these new projects. Or in order to raise finance, the companies have to issue new shares, which can be costly, or it can send negative signals to the market. Capital rationing is the process of accepting projects that maximizes shareholders' value subject to the available funds. Soft rationing happens when units or divisions in a business are allocated a certain amount of financing. This means that the firm overall isn't short of funds. It's just this unit or division has received not enough. All managers can do is try and get more funds allocated to their division. Hard rationing, on the other hand, occurs when the firm is unable to raise the financing for a project under any circumstances. This occurs when the company experiences financial distress and is in no position to raise more capital. The problem with the NPV rule when there is capital rationing is that it is a dollar value. It therefore measures success in absolute terms. This makes it difficult to select among projects of different sizes, as it will always bias towards larger NPV projects, and we may not include smaller projects, therefore making less effective use of our allocated budget. We saw in our last module NPV can be converted into a relative measure by dividing the sum of the discounted cash flows by the initial investment. This is the profitability index, or PI. Essentially, this measures the bang for your buck, the number of discounted dollars we get per dollar invested. The benefit per unit of cost, in other words. A capital rationed firm would then allocate the limited financing available to projects in descending order of the profitability index. For example, this company has 3 independent projects with positive NPV, but only has $25 to invest. Based on the NPV rule, the firm can choose Project A as it creates more value for the company. However, due to low funds, we apply the PI rule and rank projects based on their benefit per unit of cost. In that case, the firm will pick first B, then C, and ultimately A. This concludes this module.